Thank you. Emerson, you're going to need one of these papers. It's in the second bin, okay? It says student printout. Hi. Second, no. You know where the do now is? Underneath the bin in the do now. Yeah, make sure it's the one that's double-sided. Yeah, okay. All right, let's get started. So today, for those of you who looked at the printout, today we're going to be doing limits and infinity. So limits, involving infinity. If I go too fast, let me know. All right. So before we get to the actual lesson, we need to go over some vocabulary that we need in order to do the limits. We're going to be working with graphs that look like this, okay? You're going to need to draw the graph also, so this way you can make sure that you are looking at the graph when I'm talking about it. So I'm just going to draw, we'll draw this way and this way, okay? This is what we call a rational function. That means that this function will have a polynomial in the numerator and denominator, okay? Polynomials, you know, is just an expression where they have degrees of 2 or higher. So on this graph, we have something called asymptotes. An asymptote is a line that a given curve or graph, we're going to use both words interchangeably, approaches but does not touch or cross. So on this graph here, we have two asymptotes, and I'll describe the two asymptotes in a minute. If we look at this graph, we can see that this line right here is one of the asymptotes, because your graph gets, let me zoom in. Okay, does everybody have the definition? No? Yes? Yes. No? Okay. So we're still writing it. It's okay. Let's go. Mazel, you good? Let me zoom in. So if you don't have the definition, I'll zoom out in a second. So your graph gets closer and closer and closer to this line, but never touches or crosses it. The graph gets closer and closer and closer to this line, but never touches or crosses it. It also gets closer and closer and closer and closer to this line, bless you, but does not touch or cross it. Okay? These two things are called asymptotes. These two things are called asymptotes. In general, an asymptote is a line or lines that your curve gets closer to. So these are what we're going to use to do limits to infinity. So we have two specific asymptotes. The first one we have is horizontal asymptote. A horizontal asymptote is a horizontal line a line that goes left and right. That has a specific value. The function approaches as x increases, as x decreases to negative infinity. So as x approaches, I am off screen, aren't I? There we go. Or as x approaches positive infinity. Sorry, does the sentence not make sense? Did I forget a word? Let me see. Having a specific value. Oh, shoot. Wait. A horizontal line having a specific value, the function approaches, as x approaches positive or negative infinity. I know that doesn't make sense without a picture, but we're going to show you right now, okay? So what that means is, let's say that this value right here is 1, okay? Your graph then, as x decreases, so remember we're talking about negative infinity over here and positive infinity over here. Because your x is getting smaller, your x is getting bigger. So as we approach negative infinity, so as your graph gets closer and closer or extends out or gets infinitely smaller, your graph will approach this line here, which is positive 1. That is a horizontal asymptote. This is a horizontal asymptote. It's the line that goes left and right. This will have a specific value, meaning you will get a specific number, okay? You will get a specific number. Always. Always, always, always. I'm sorry? Yeah. More? Oh. Gotcha. Right there? Okay. The next asymptote we have, do you need me to go back up? Okay. The next asymptote we have is a vertical asymptote. A horizontal asymptote is a vertical line. Oops, not line. It goes up and down. Bless you. That guides the graph. Please let me know when I'm off screen, okay? Of the function to positive infinity or negative infinity. But it will not approach a specific value. Am I off screen? Okay. A lot or a little? There. Is that good? You said no? Oh. Approach a specific value. I'm waiting for everybody to write the definition, then we're going to go back up to the picture. Ready? Okay, let's look at the picture. So we've seen a horizontal asymptote. The only thing left is the vertical asymptote. That is this line right here. This is your vertical asymptote. As you can see, hopefully, as you can see, this function will never approach a y value. It will never, ever get close to a y value. That is why this is going to go to positive infinity up here because it's increasing infinitely in the positive direction. And this one will go to negative infinity because it's decreasing in the negative infinity direction, infinitely. Okay, so the up-down is a vertical asymptote and left-right is a horizontal asymptote. Any clarification needed before we get to the notation and then the examples? Are we sure? Are we sure? Are we sure? Are we sure? Okay. All right, I'm gonna zoom out. Alpha. Here you go. Who's next? All right. Limits and infinity notation. So we're extending our information on limits, but now we're including infinity because graphs aren't perfect and they don't just stop at certain spots. Graphs can go on forever. So we'll start with the horizontal asymptote and its notation for limits. So because we're talking about the horizontal asymptote, the x values will approach positive or negative infinity. Okay, your x values will always approach for horizontal asymptotes positive or negative infinity, because those arrows that show infinity will not approach a specific x value. So the limit is going to look like this. So that means we're going to look at what happens to the graph as your arrow goes to the left. Okay? We're going to look at what happens to the graph as your arrow goes to the left. The arrow of the graph. This will always be some number. Okay? It's always going to be some number. Always. Always. 4, 5, pi, square root of 2. Okay? Don't write on my desk. Don't write on my desk. But we also have the limit as x approaches positive infinity. Here, we're looking for what happens as your x values increase as they go to the right. So we have a left for negative infinity, and we have a right for positive infinity. We do not have a regular limit. You know how we have a left, a right, and a regular? For this, we don't have a regular limit because there is no way for me to see what happens when it goes to infinity, because when we talk about that, we're talking about, excuse me, we're talking about how it, if we say the limit as x approaches infinity, we're assuming it's positive. Okay, we can't just say infinity and get rid of the negative. So we only have two notations for the horizontal asymptote. All right, last notation, and then we will get to the example. Vertical asymptote. Oops, I put these two backwards. Oh, whatever. Same thing. We have three notations for this, and that is because we will have some kind of x value to evaluate. So we'll have a specific x value, specific. Let me write this better, sorry. Can you see that? Anybody? No? Yes? Nobody's saying anything? Hey, I'm tired too, but I'm up here teaching still. Can we see this one? Thank you. So we have a specific x value here to evaluate. So first one we have is the left side limit, like always. X approaches a from the left of f of x. But now, can I move down? Does everybody have this one at top? Okay. Now, we're going to have either positive or negative infinity. Okay? We have a positive or negative infinity. Your graph is going to increase infinitely up, or your graph is going to decrease infinitely down. Then we have a limit as x approaches a from the right of f of x. Again, can go to positive or negative infinity. And because we have a specific a value, we can evaluate the normal limit. That one will be the limit as x approaches a. And this one can be positive infinity, negative infinity, or what do we think? If these two don't match, what is it? Does not exist. When you're done writing that down, take out the example sheet. Am I going too fast? Okay. Am I? Just people take a little bit longer to write. Language. I'll have this video posted by tonight for those of you who need like an extra.
Where's the video recorded?
Where? What do you mean?
No, but like when you record it.
On here.
Can you hear us?
Yeah. Obviously they can hear, if I'm speaking and you can hear the video, obviously you can.
But I'm not that good though, right?
No, because I'm like right by the mic. The mic is, where is the mic? I don't know, the mic is somewhere over here. That's your free turnaround. Okay, can I go to the example? Are we good? Are we good? Okay, seniors. This is an honors level class, and I am very embarrassed by how many seniors were still not getting level 1. It's okay. I understand that this is new. and that. But all we're doing for level 1, literally, is we're taking a sentence and putting it in math. That's it. That's all we're doing. So if you are still confused on level 1, don't be embarrassed. I'm going to go over it. I guess I assumed that you can just write from words to math notation, so that's my bad. Even though this is an honors class. What is the abbreviation for limit? LIM. Very good. Any questions on that? I'm gonna go a little bit faster on this part. I hope that's okay. Okay. X approaches. What is the sign for approaches? Arrow. Negative infinity. Oops, maybe I choose a different color. Negative infinity is just negative infinity. Questions so far? No. F of x. F of x equals 4. Equals 4. Questions? Are we sure? None of your business.
None of your business.
You said, did you get that wrong or who got that wrong? People got that wrong. Okay. Next one, limit, LIM. Do I need different colors? Sure? Okay. X approaches. 10. F of x. Now, seniors, because in math, when we say equals something, right, it is a specific value. It is a specific value. I cannot equal infinity. I don't know who's after Kimberly. I cannot equal infinity. So it is going to say approaches, but you will write equals negative infinity, okay? I cannot say it equals negative infinity, but in my math notation, I can write an equal sign, okay? Kimberly, I don't know which one you need. Okay, questions on that? Can I get to the harder one? Yes, no, maybe so? All right. Okay, thank you. Hey, you two stop. Oh, I'm gonna remove you. Would you like to try me? Ask fourth period. Okay, let's look now at this. We are looking at 3 from the left, okay? On these graphs, until we get to like quarter 2, maybe quarter 3, the asymptotes will be written for you, okay? I may forget, okay? If I forget, you could just ask. But as you can see, that this right here is my asymptote of 3, okay? I'm looking at 3, 3, and 3. First thing I'm going to do is I'm going to look at 3 from the left, okay? 3 from the left, which means I need to go from the right to the left, just like if it was like a regular graph. I need to start in the right and go to the left. So if I go to the right and go to the left, where are my y values going to? Negative infinity. They're going to negative infinity. It's not going to a specific y value. And we're not looking for the x value. We're looking for the y values. So this is negative infinity. Any questions on that? Senior? No question? Sure? Okay. Huh? Okay, so you're following your graph. It's fine.
What the point is? Why you?
There is no point.
There is no point.
That's why.
Why is there no point? Because your graph goes on forever in that direction.
I know, but like, this is gonna be the same answer problem.
No.
Right?
No.
Pay attention as well.
Yeah.
Alright.
So now let's look at 3 from the right. Here's 3. So I'm going to trace my graph and try to figure out where is it going. Where's it going? Positive infinity. So you see, it's not the same answer. Okay? So then, what is my limit for 3? Why? They're not the same. Okay? Questions? Are we sure? Get it? Yeah. You want me to wait? Or you got a question? You want me to zoom in? Where do you want me to zoom in? You're good? Okay. Are we sure?
Yeah.
Okay, cool. All right, now let's look at negative infinity. All right, I need you to pay attention. Like, some of you like, oh, I get it. And then you're gonna come here and not get it. Students think that because this is negative infinity, I need to go back down here and look at negative infinity. No, what you're looking at are your x values, okay? These are x values. X values. Your x values, can you see that, kind of? Okay. So if we looked at our x-axis, we have -1, -2, blah, 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 goes to negative infinity, okay? So we're looking at the left side of the graph and where this part of the graph approaches. I'm going to use this. So if I continued on, what does it look like my graph's going to get closer and closer to? -3? No. 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 Okay.
0.5.
No.
1.5.
No. I need another. Oh, here we go. Highlighter.
1.5
Okay.
and a half.
You see this? Bless you.
Ladies,
It's going to what? 2. It's going to 2. Do you see that?
wait, why is it going to 2?
Why is it going to 2? So, let me zoom in. Come on. All right. So here's the graph, this black line, right? So I'm going to extend it out as far as I can, and I'm going to try to... But it is. But it is.
You sure?
Yeah. Okay.
So that means this one is 2. The one going down.
This one?
Yeah. Nah, that one going down. This one's gonna hit 3.
No, it's not. Where is this going to hit?
Nah, look at the one on the bottom.
Wait. Yes. This to positive infinity is going to hit 3. This, what do you mean on the bottom?
The other one, the other one.
This other arrow?
Yeah.
Okay, so, but we're looking, hold on, let me finish this one. So this is positive infinity, stop whistling, thank you. This, we're looking at what happens when it goes here, okay? For positive infinity,
Yeah.
okay? This, what happens, we're asking what's going on here at negative infinity. This is the y value, Rafa.
Yeah.
These are y's, this is x's. Y's, x's. When we point up and down, that's y's. When we point left and right, that's x. Okay? That makes sense? You sure? Okay. Any other questions? Are you sure? All right, then flip over. You have 10 minutes to complete the other side before I go over the answers. 10 minutes in your group. Go.